Alrighty, we're going to start the Unit 6, Section 4 notes. This section, we're going to talk about least common multiples. So as you know, multiples are the product of a number and any other non-zero whole number. So I like to think of multiples as the numbers you say when you're counting by a number. For example, the multiples of 4 would be 4, 8, 12, 16, and so forth, compared to factors, which are different. So a common multiple between two numbers is just a multiple that is shared. And a least common multiple is the least common of all of the shared multiples between two numbers. All right, so we're going to first review how to find the LCM of two different numbers. So just like the example I gave earlier, we're going to find the multiples of 4 first. So, and I'm going to list those out to the side. So those would be 4, 8, 12, 16, 20, 24, and 28. I could keep going, but I'm going to stop there just because I think I may not need to go any further since I need to do 14 as well. So now I'm going to write 14, the multiples of 14. So that would be 14 and 28. Sure enough, I have found my common multiple, which is 28. And in this case, this would be our least common multiple. Let's do another example. I'm going to write the multiples of 18. So those would be 18, 36, 54. The multiples of 27 would be 27, 54. I have found a multiple that is shared, so my LCM is 54. All right, I'll go ahead and do number 3 as well. The multiples of 5 would be 5, 10, 15, 20, 25, 30. I'm going to go ahead and stop there for now to see if I can use those numbers to find my LCM. If I do the multiples of 10, I have 10, 20, 30. Okay, those two numbers share 30, so perhaps I can find 30 when I do the multiples of 15 as well. So 15 would be 15 and 30, and there we have it. That is our least common multiple, 30. You'll notice that 30 has to be shared by all three numbers in order to be our LCM. I will let you try number 4. Again, you're simply listing the multiples of each number and finding the one that is the least common multiple. All right, so this section is probably new to most of you. We're going to talk about finding the LCM of not just numbers, but monomials. So in our first example, we have two monomials, the first one being 5a, the second one being a squared. So when we do this, we're actually going to do it in two parts and put the two parts together in the end. The first part is to find the LCM of the two numbers that you have, or however many numbers there are. In this case, we only have one number, so our LCM is simply 5. We then are going to write our variables. So we have a, and we have a squared. In order to find our LCM, we're going to take the one with the higher power. So in this case, a squared would be the higher power. And then we're just going to multiply that higher power by our number. So our LCM of these two monomials is simply 5a squared. In number 2, we do have two monomials, 3 times g to the 5th power and 20g squared. Our first step, remember, is to find the LCM of the two numbers present. So if I wanted to find the LCM of 3 and 20, I could simply list all of their multiples. When I do it for 20, I know that the multiples would be 20, 40, and 60. And I can already tell without listing all of the multiples for 3 that 60 is going to be our LCM. If you needed to write them out for 3 in order to see that, feel free to do so. Our next step is going to be to look at our variables. So we have g to the 5th power and we have g squared. We always take the higher power. So in this case, we're going to take g to the 5th power. We're going to multiply these two together. So our LCM equals 60 times g to the 5th power. All right, another example. We have two monomials here, 21m squared n and 84m n cubed. Let's go ahead and find the LCM of 21 and 84. So we would have 21, we would have 42, we would have, I'm going to add 21 to this. Whoops, that should be a 6. 63. And next would be, if we add 21 again, I have 84. All right, I'm just going to erase my work here so that we have more room. But as you can see there, that would be how you would find the multiples. So 21, 21 times 1, 21 times 2, 21 times 3, 21 times 4. I can already see what our least common multiple is going to be, as our second number is in fact 84. So now let's look at our variables. We have m squared and m, and we have n and n cubed. So we're going to take the higher power of each. So m squared and n cubed, if we put them all together, our LCM equals 84 m squared n cubed. Alrighty, looking at number 4, we don't have any numbers to worry about with these monomials. We simply have variables. So we're just going to take the highest power of each variable. So for r, the highest power that we have is r squared. For s, the highest that we have is simply s. And t, our highest power is t to the 4th. So r squared s t to the 4th would be our LCM for those three monomials. All right, so in order to compare fractions, we can find the least common denominator to determine which fraction is greater. Remember, you can't simply tell which fraction is greater by looking at them or by drawing a picture. It's best to use the LCD. So the way in which we would do that we would find the least common multiple of 3 and 8, which in this case is 24. So we're going to set 1/3 equal to 24, 24ths, and 3/8 equal to 24ths as well. Now I want to think to myself, how do I go from 3 to 24? I multiply by 8. I need to do the same thing to the numerator. So I'm going to multiply the numerator by 8. So 1/3 does in fact equal 8 24ths. 3/8, to go from 8 to 24, we're going to multiply by 3. We need to do the same thing on the top. So we would have 9/24. Because we have the same denominator now, we can compare them. 9/24 is greater, which means that 3/8 is greater than 1/3. I'm going to let you try number 2. Again, you want the same denominator in order to compare the two fractions. In this last example, we're going to do the same thing. It's just written as a word problem. So in April, it rained 7 out of 30 days. And in May, it rained 8 out of 31 days. We can use the common multiple of 950